Hello everyone. In this video, we'll be solving questions from the Momentum Worksheet. Before we start, I'll quickly revise what is momentum. Momentum is the measure of motion of an object. The formula of momentum is given by P equals m into V, where m is the mass of the object and V is the velocity of the object. Along with it, we also learned one more quantity called as change in momentum. Change in momentum is also called as impulse. Impulse is change in momentum. Change in momentum is represented by delta P. So that is our impulse. We know from the formula force is rate of change of momentum, delta P by delta T, or we can also write delta P is equal to force into delta T. This is one more formula to find momentum, change in momentum, which is impulse. In simpler words, the change in momentum, delta P, is nothing but the final momentum minus initial momentum. Okay. So if you take the difference between the final momentum and the initial momentum, you'll get the change in momentum, which is same as impulse. First, we'll go through the first question. Let's read the first question. An object of mass 50 kg accelerates from a velocity of 2 meter per second to a velocity of 10 meter per second in the same direction. What is the impulse provided to cause this acceleration? First, we need to find the impulse of the object. We'll see what is given to us. We know the mass of the object. Mass is 50 kilograms. Then we have initial velocity is 2 meter per second, and final velocity is 10 meter per second. If I want to find change in momentum, which is final momentum minus initial momentum, we can write this as mass into final velocity minus mass into initial velocity. So m1 vf minus m1 vi. Mass is 50 kilograms, so 50 times final velocity is 10 minus 50 times initial velocity is 2. So which is 500 minus 100, that would be 400, and the unit is Newton seconds. There are two units for momentum. Both momentum as well as change in momentum has the same unit. Since it is mass into velocity, we can write that as kg. That's a unit for mass. Velocity has a unit of meter per second. So this is one unit for momentum. The other unit is, we can write P is equal to Newton seconds. Okay, there are two units. Here they have given us in terms of Newton seconds. The correct answer is option B. We'll go to the next question. A gas molecule strikes the wall of a container. The molecule rebounds with the same speed. Now, what happens to the kinetic energy and what happens to the momentum of the molecule? Now, kinetic energy is the energy which arises due to motion of the object. If the object is moving, then it has kinetic energy. Kinetic energy depends on velocity. The larger the velocity, larger the kinetic energy. If an object is going at a speed of something like 100 km per hour, its kinetic energy is large. If the same object is going at the speed of 5 km per hour, its kinetic energy is small. So let's see what's happening to the kinetic energy. What's happening to the speed of the molecule? The speed remains the same before and after collision, which means the kinetic energy will remain the same before and after the collision. So we'll say kinetic energy should be same. But let's look at momentum. We know that momentum is a vector quantity. Momentum is mass into velocity, and velocity is a vector quantity. Here, if the object is moving towards right, then velocity is in the right direction. So we can call it as some positive value of velocity. Let's say something like 10 meter per second. But if the object is going in the opposite direction, then velocity will be negative. So here let's say it's going in the positive x-axis, but here it is going in the opposite direction. Let's say it's going in the negative x-axis. So even the value of the momentum will be negative because value of velocity is negative. So in this case, since it is bouncing back, the velocity will become negative. So the momentum changes. If so, let's say initially the momentum was 100 Newton seconds, right? If before hitting the wall, after hitting the wall, since it's coming in the opposite direction, the momentum will be something like minus 100 Newton seconds. The value of momentum remains the same because the mass remains the same, and they're saying the speed remains the same. So if mass and speed both are the same, then the magnitude of momentum will remain the same. So the answer is option C. The kinetic energy stays the same, whereas the momentum changes. Alright, let's look at the third question. Which quantity is measured in Newton seconds? First, let's write down Newton seconds. So 1 Newton is the unit of force. We know force is F is equal to ma, mass into acceleration. We can write mass into acceleration times seconds, and we know mass has a unit of kg and acceleration has a unit of meter per second square times second is in the numerator. So here this square and this will get cancelled. We have kg meter per second. Now kg is a unit of mass and meter per second is a unit of velocity. Now we have to think which unit is given by m into v, mass into velocity. That would be momentum. But here we don't have momentum, but we know both momentum as well as impulse as well as momentum share the same units, because impulse is nothing but change in momentum. Let's say if it is let's say in the previous question, we know before hitting the wall the momentum was 100 Newton second. After hitting the wall, the momentum was minus 100 Newton second. That means the change in momentum is final momentum minus initial momentum. So minus 100 minus 100, which is minus 200, and still the unit is Newton seconds, right? That is the change in momentum. But the change in momentum or impulse also has Newton second as a unit. So in this question, we can say impulse is the right answer because both impulse as well as momentum share the same units. Alright, so that's all with this worksheet. If you have any more doubts, you can put an email to my you can put an email. Yeah, okay, thank you.